Previously, we learned about instance rooms and instance worlds and the differences between them. But did you know that instance rooms and instance worlds have their own shared data space separate from DataStore? This can be a great way to communicate critical data between your rooms and world instances. Let's dive in. Shared memory allows shared storage database across all your world instances. This is different from your data storage, where data storage is meant more for persistent data, things like player information, progress, world events, things like that, whereas shared memory is more volatile in nature. So it is meant as a temporary space to communicate information and store information that is utilized between world instances. So this is specifically meant for communication of data between your world instances. Whereas data storage is more globally utilized and is more persistent, and it's meant for data that is intended to last between play sessions. There are certain limitations with shared memory. First, we have the naming convention. We can only use alphanumeric letters and numbers for the variable names. We can use spaces, and we can only specifically use the underscore, the backslash, and the dash symbol for the naming. We also have size restrictions, so we can have 100 shared spaces per world. So essentially what this means is that this box right here is a single shared space. We can have 100 of these. So each shared space has a shared variable in it. Each variable can hold a maximum of 80 kilobytes, and the total capacity per shared space is 80 megabytes. So again, 100 maximum shared spaces, 80 kilobytes per variable, 80 megabytes per shared space. When you're getting and setting from the shared spaces, you can have a maximum of 100 get-set calls per minute across all your instances. Let's take a look at an implementation example of how to utilize shared spaces in MapleStory worlds. So before we take a look at the code, let's look at what we're going to try to get working today. So we have our button up here, and every time we enter into an instance room, we're going to create a variable and we're going to update that variable. So currently the value is 1, so we're going to click OK and return back. Every time we move in, we're going to increase that value. We can see the value is now 2. And let's say I added another player. If this new player now enters into the room, we can see the value is 3. And this value is still the same for other players. So if we now all leave and we come back into the room, we can see the value is 4 for everyone. So this is a shared variable that we are saving across our world instance. Now let's take a look at how this system might be implemented. So first thing we're going to do is we are going to open up our scene management script. And in here, we're going to create a couple of functions to allow for the creation and management of a number. So first, we're going to add a method called createSharedNumber. And this is going to allow us to create a shared variable and specifically use a number type. So shared memory always operates on strings, but essentially what we're doing is we're going to be converting back and forth between a number type. So when we create the shared variable, we're typecasting the variable into a string type so that it can be saved inside of this create variable. So first, we're going to use room service, and we're going to call getSharedMemory, and that is going to take in the space that we define for the shared memory. If we're able to successfully get our shared memory, then we are going to create a variable. So we're going to create the new variable, we're going to pass in our variable name, and we're also going to pass in our value that we're going to assign as an initial value for this variable. Then if it's not successful, meaning the code does not equal share result memory code.ok, then we're going to log out an error saying that our set failed. Next, let's add the ability to get our shared number. So we've created up here, and now we're adding the ability to get our number here. So we're going to pass in the space. So this is going to be the same space when we're calling it. Otherwise, if we pass in a different space, it's going to be from a different space. So the variable name may not match. So when we're calling this, we're going to create the shared number with a certain space. We're going to pass the same space into the get shared number. We're going to get shared memory again. Same logic for checking if it exists. Then we're going to get a variable, pass in the variable name, and we're going to get the counter. So this is going to start as a string type. If we were not able to get the string, that means this variable does not yet exist. So we're going to set the value initially to 0, and then we're going to call the create shared number that we just created to create the variable, and then we're going to pass in our initialized value, which is 0. If it already exists, then we're going to simply get the information from the get variable. We're going to typecast it into a number type, and then we're going to return that as our value. Finally, we're going to have a way to update our shared number. So this will allow us to change the value of our shared number. So we're going to pass in the space again, the variable name, and the value to update our variable. So again, we're getting the shared memory, checking if it was successful, and then we're going to pass in our get counter, and then we're going to create a new variable, get counter, and then we're going to get the variable with the variable name. We're going to check if it was successful. If it wasn't successful, we're going to create a shared number. Otherwise, we're going to do the typecast again to get the value of our shared number. And then we're going to create a shared variable key information. So this is important because when we're managing and operating with shared variables across multiple instances, we're going to be accessing it often across variable instances. So different instances may have specific timings for accessing this variable, and they might kind of fight for this variable. So to make sure that we are getting the correct version of our variable, we have what's called an Etag. So this will make sure that we have the latest version of our variable. So this is why it's important to use update variable and wait to pass in our key information. So this is going to be the current variable that we got, and we're going to pass in the name of our variable as well as the Etag, and we're going to create a variable key information. Then if the value exists, then we are going to pass in our key information along with the Etag, and then we're going to set our new variable to the value that it got plus 1. So basically we're incrementing the value of our variable. So this is our updated variable. If the updated code equals shared memory result code dot precondition failed, that means that there was an Etag mismatch, and we weren't able to get the correct version of our shared variable information. So something that you might want to do is maybe do a wait function, a timer wait function, and then try calling this function again after a certain amount of time to make sure that the Etag mismatch error no longer happens. So in the case where the Etag mismatch occurs, you might want to try it again after a certain amount of time. In this example, we have not implemented that system. Now that we have our various shared memory functionalities, let's actually implement that into our existing game system. So inside of our move players to instance, inside of this function here, we are going to create our shared number. So here we're going to get the shared number. We're going to name our shared number as global counters, and we're going to name our variable as my counter. And we're going to use that, and we're going to update this shared number, global counters, my counter, and we're going to increment that value by 1. Then down in the handle room entered event, we are going to load the shared memory value. So if our current room key contains the word main in it, which means that it is a static map, so our room key is going to be the value of our instance map. If it's a static map, then it's going to be main. So for static maps, we are not going to call this function, but as soon as we enter into an instance, we are going to show a pop-up. So we're going to get the value that we say stored up here, and we are going to get our myCounter variable from the global counter shared storage. And if it exists, then we're going to show a pop-up with that value. So we're going to pass in our user ID to the show pop-up method so that we can target this specific user to call this function for. Otherwise, if we did not pass this in, then all users will be receiving this message. So every time a player enters, we're going to see this pop-ups, which is not desired. So let's add our show pop-up method right up here. And notice that we only have one variable, the value of our myCounter, and we don't have this user ID parameter here. And this is because when we're going from a server-side method to a client-side method, we can pass in an optional parameter with the user ID. So this is going to be the target user ID that we're going to specifically send this message to only this user ID and not the other clients. Then we're going to show this pop-up. We're going to use the UI pop-up open, and we're going to set the value to the value is, and then we're going to concatenate that with the value, and then we're not going to have our onOK and onCancel callback methods. The way that our UI popup works is that it will enable and disable the popup group. So in this template, we have a bunch of different popups. And because we are enabling and disabling this entire group, nothing will actually be visible. So we want to only have the basic popup enabled, and we're going to disable the popup group because our logic is going to enable and disable this entire group so that only the popup is visible. Let's save that and let's press play. Let's start with our first player without creating a second instance, and let's enter. And of course, we have to make sure that we refresh. And we can see that our value is 1. So let's create another instance. We're going to click OK. And we're going to enter into the world instance, and we can see the value is 2. If we move back and then enter again, we can see the value is 3. So we have successfully utilized our shared storage memory space to store a variable and increment that variable. For world instances, it's very much the same thing. So as far as the limitations for shared spaces go, as well as the usage, it's nearly identical. So what we're just going to do is we're going to copy this entire code, and we're going to paste this straight into world management. And the only thing we're going to change is in instance rooms, we use room service. In world instances, we use world instance service. So simply replace the room service to the world instance service, and it will work in exactly the same way. Because we already saw how this works, we're not going to try implementing this again, but just know that world instance service and room service, the way shared memory works is exactly the same. Today we learned about shared memory utilization and how it differs from DataStore. We hope you've learned a lot today that you can use for your own implementation of shared memory in your own worlds. Thanks again, and happy creating!